Hello and welcome to chemistry class. Today we will learn about solutions. In our day-to-day life, we rarely came across pure solution. We are surrounded by solutions as for example, medicine, an edible thing or an antiseptic liquid. These solutions are composed of many components. So that's why the study of solution is very important for us to understand it better. So, solution is defined as the homogeneous mixture of two or more components. Solvent is the component whose physical state is the same as that of solution. In case both the components are in the same phase, solvent is the component which is in the largest proportion. Generally, the component that is present in the largest quantity is known as the solvent. Solvent determines the physical state in which solution exists. One or more components present in the solution other than the solvent are called solutes. In this unit, we shall only consider binary solution. That is, it consists of only two components. Now we will see the types of solution. So there are mainly three types of solutions: solid solution, liquid solution, gaseous solution. So in solid solution, the solvent is solid. In liquid solution, the solvent is liquid. And in gaseous solution, the solvent is gas. The solute may be solid, liquid and gas, with which the composition is made. So below in the table, each component is summarized with example. We will focus only on liquid solution in this chapter. Now let us see how these solutions are expressed. So composition solution are expressed by its concentration. Let us take an example to understand. Here we can see the composition of a generally used disinfectant. Here in the composition there is a term that 50% C14, 40% C12 and 10% C16. So what are those? Those are the concentrations. So there are several ways by which we can describe the concentration of the solution. So the ways are mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity, and molality. Now let us define each of the term in brief. Mass percentage, weight by weight. The mass percentage of a component of a solution is defined as the mass percentage of a component equal to mass percentage of the component in the solution divided by total mass of the solution into 100. For example, if a solution is described by 10% NaCl in water by mass, it means that 10 gram of NaCl is dissolved in 90 gram of water, resulting in 100 gram of solution. Concentration described by mass percentage is commonly used in industrial chemical application. For example, commercial bleaching solution contains 3.62 mass percentage of sodium hypochlorite in water, defined as the volume percentage of a component equal to volume of the component divided by total volume of the solution into 100. For example, 10% ethanol solution in water means that 10 ml of ethanol is dissolved in water such that the total volume of the solution is 100 ml. Solution containing liquids are commonly expressed in this unit. For example, a 35% volume by volume solution of ethylene glycol and antifreeze is used in cars for cooling the engine. At this concentration, the antifreeze lowers the freezing point of the water to 255.4 Kelvin, that is minus 17.6 degrees Celsius. Mass by volume percentage, that is weight by volume. Another unit which is commonly used in medicine and pharmacy is mass by volume percentage. It is the mass of the solute dissolved in 100 ml of the solution. Parts per million. When a solute is present in trace quantities, it is convenient to express concentration in parts per million, that is ppm, and it is defined as parts per million equal to number of parts of the component divided by total number of parts of all component of the solution into 10 to the power 6. As in the case of percentage, concentration in parts per million can also be expressed as mass to mass, volume to volume, and mass to volume. A liter of seawater, which weighs about 1030 gram, contain about 6 into 10 to the power minus 3 grams of dissolved oxygen. Such a small concentration is also expressed as 5.8 gram per 10 to the power 6 gram, that is 5.8 ppm of seawater. The concentration of pollutants in water or atmosphere is often expressed in terms of ppm. Mole fraction. So mole fraction is defined as the mole fraction of a component equal to number of moles of the component divided by total number of moles of all the component. It is denoted by the symbol X, and the subscript used for the right hand side of X denotes the component. For example, in a binary mixture, if the number of moles of A and B are Na and Nb respectively, the mole fraction of the A will be XA equal to Na by Na plus Nb. For a solution containing I number of components, we have this equation. It can be shown that in a given solution, sum of all the mole fraction is unity. That is, mole fraction unit is very useful in relating some physical properties of the solution, like vapor pressure with the concentration of the solution, and quite useful in describing the calculation involving gas mixtures. Molarity. Molarity M is defined as the number of moles of solute dissolved in 1 liter or 1 cubic decimeter of solution. That is, molarity equal to moles of the solute divided by volume of the solute in liter. For example, 0.3 mole per liter or 0.3 m solution of HCl means that the 0.3 mole of HCl has been dissolved in 1 liter of the solution. Molality. Molality small m is defined as the number of moles of the solute per kilogram kg of the solvent, and it is expressed as molality m equal to moles of the solute divided by mass of the solvent in kg. For example, 1 mole per kg or 1 m solution of KCl means that 1 mole, that is 74.5 gram of KCl, is dissolved in 1 kg of water. It is to be noted that mass percentage, ppm, mole fraction and molality are independent of temperature, whereas molarity is a function of temperature. This is because volume depends on temperature and the mass does not. Today we have learned about that what is a solution, what are the different type of solution, and how solution are expressed in terms of concentration. So we will continue this chapter in the next class, and thank you very much.